Hey everyone, welcome to lesson 2.7, Determinants of Matrices notes. So basically a determinant is it looks kind of like finding the absolute value of a matrix. And basically every square matrix, meaning that it has the same number of rows and columns, so like 2 by 2, 3 by 3, 4 by 4, etc., is associated with a number, kind of like the absolute value, but it's called the determinant. And the determinant provides important information about the matrix without having to solve. So, for instance, you can find inverses, you can find solutions, and you can find the area of a triangle using the determinant. And you can't do these three things in this specific way without finding the determinant. Okay? Only square matrices have determinants. Okay, so you can't do it with a 3 by 2 or a 2 by 3 or a 4 by 5. Has to be the same number. Inverses is what we're going to talk about in two sections, so for 2.9. But basically, if the determinant is not 0, then the matrix has an inverse. That's what it tells us. And then we use that information to find the inverse. It also tells you that it has one solution. So all of the matrices that have no solution or infinitely many solutions are going to have a determinant of 0. Okay? And instead of solving using row operations, you can multiply by the inverse, but we'll get to that in 2.9. Cramer's rule is a formula that uses a matrix to find the solution to a system of equations that uses the determinant. Sorry, I guess I should have said determinant there. So instead of using row operations to solve this way, you just do a bunch of calculations with the determinant, and it's a formula based on the determinant. And then the area of a triangle is if you only have 3 coordinates, the vertices, rather than like the base and the height of a triangle, you can use a matrix to find the area of a triangle. So these are the 3 most important applications of determinants. We're going to talk about these two in 2.8 and inverses in 2.9, but it's probably the most widely used case of determinants. All right, so what does a determinant look like and how do you find it? So if I want to find the determinant of this matrix A, I can either write DET parentheses A, DET standing for determinant, or I can write it in absolute value bars like this. And those are not absolute value bars, kind of like this. They mean determinant. Okay? And the determinant of this is the two diagonals being subtracted from each other. So A times D, that's one diagonal, minus B times C, which is the other diagonal. So that diagonal minus this diagonal. So you just subtract them. Okay? So for example, the determinant of this one right here would be 6 times 3 minus 2 times negative 3. And we won't write out that multiplication every single time, but I'm doing it just for this first one. So 6 times 3 is 18, minus 2 times negative 3 is negative 6. Well, that turns into 18 plus 6, which is 24. So the determinant of this matrix is 24. The determinant is a value, meaning it should be a number. It could technically be a decimal if you saw decimals inside of the matrix, but for the most part, it'll be a whole number. Okay, and this one said find determinant of A like this. This one just says evaluate because it gives you the straight up and down bars without the little, I call them like the little legs in between. Okay, so it's the same thing. This is the same thing as this. Okay, so we're going to do this diagonal. 5 times 4 is 20, minus this diagonal. 2 times negative 9 is negative 18, Well, that's going to turn into 20 plus 18, which is 38. Then we're going to use it to find the value of x. So same idea is going to follow, but you'll notice that one of the pieces is missing. Okay? And we know what the determinant is this time. So same idea, negative 2 times x is just negative 2x. Then, in the other diagonal, 5 times 3 is 15. And we subtract them. So negative 2x minus 15 equals 25. Guys, this is just a regular equation. You're going to add the 15 to the other side. 25 plus 15 is 40. Divide by negative 2 on both sides. And x is negative 20. We could even double check if we wanted to. Negative 2 times negative 20 is 40. 40 minus 15 is 25. Okay, this one's a little bit trickier. This first diagonal is 9x minus the other diagonal. 6 times negative 4 is negative 24 equals 12x. So there's an x on both sides. Don't let that freak you out too much. Do go ahead and make this double negative a plus sign. And then I want this 9x to go join the other x's on the other side. 24 equals 12 minus 9, 3. Well, it just means x is 8. Now let's talk about how to the determinant of a 3 by 3. This one's a little bit more complicated because it's a bigger matrix, and it doesn't work quite as simply. This could also continue to be a 4 by 4, the same method would follow, but it gets a little more complicated the more rows you add. We're not going to do a 4 by 4. We're just going to do 2 by 2s and 3 by 3s. Okay, so over here I've just filled in with random letters. But what you're going to do first is copy column 1 as column 4. What I mean by that is take this entire column and rewrite it over here. And then do the same thing, make column 2 column 5. So we want a 3 by 5 matrix. And I'll show you why we want a 3 by 5 matrix in just a second. So basically we're just adding, this column is going right here, and this column is going right here. You're copying these two to the end, just not the third one. The third one just stays in the middle. Then what you're going to do is multiply all values in each right diagonal. What I mean by a right diagonal is this one, and this one. And the whole reason we needed those 2 extra columns was so that we could continue our diagonals all the way across. Each diagonal should have 3 values in it. We don't want these little diagonals that only have 2. We want the full diagonals, like this. So these are my right diagonals. So negative 3 times 2 is negative 6. Negative 6 times negative 3 is 18. 4 times 3 is 12. 12 times negative 5 is negative 60. 6 times 0 is 0. Doesn't matter what's down here because we have that magic 0, and when you're multiplying by 0, everything else becomes 0. So that's step 2, is multiply the values in each right diagonal. Okay? And then we are going to add them together. So we're adding all 3 of these. Negative 18 plus negative 60 is negative 42. I forgot my negative. There we go. And then plus 0 is still just negative 42. Then you're going to do the same type of thing And since I've already used up all my colors, I'm going to go with highlighter along the left diagonals. So this same thing, but they're going to be going to the left. So those three. Okay. And there we go. So right here, 6 times 2 is 12. 12 times negative 5 is negative 60. Negative 3 times 3 is negative 9. Negative 9 times negative 1 is positive 9. And hey, 4 times 0, there's that magic 0 again. 0, 0 times negative 3 is just 0. So then we need to add together all of those. Negative 60 plus 9 is negative 51. So right now, I have the right diagonals, which added up to negative 42, and my left diagonals, which added up to 51. And then we need to subtract right minus left. So for this problem, that's going to be negative 42 minus negative 51. Okay, so right minus left. And that turns into a big old plus. Negative 42 plus 51 is positive 9. So the determinant of this big bad boy was 9. Okay, the second and third ones become way easier because now you've seen it once. Or it becomes more easier the more you do it. Kind of like multiplying matrices did. Okay, so I'll do it one more time over here on the right. Start by rewriting the first two columns. Okay, so I'm just copying this one right here, this one right here. And then I'm going to multiply together all of my right columns. Okay, so I want this one, and this one. Okay, so that's 4 times 5 is 20. 20 times negative 4 is negative 80. Negative 4 times negative 3 is 12. Times negative 3 is negative 36. 2 times negative 4 is negative 8. Negative 8 times negative 2 is positive 16. And I'm going to add those three together. Negative 80 plus negative 36 is negative 116. Negative 116 plus 16 is negative 100. You can also use a calculator to add if you need to. And then I'm going to do the left columns, which starts in the middle and goes the other direction. Okay, so 2 times 5 is 10, times negative 3 is negative 30. 4 times negative 3 is negative 12. Negative 12 times negative 2 is 24. Negative 4 times negative 4 is 16. 16 times negative 4 again is negative 56. Nope. Sorry, 64. I don't know where our multiplication facts are today, guys. 4 times 4 times 4 is 64. And because there's 3 negatives, it's still negative. Okay, 30. Negative 30 plus 24 is negative 6. Negative 6 minus 64 is negative 70. So now you have your two sums and you're going to subtract them from each other. So negative 100 minus negative 70 is going to become plus 70, which is negative 30.